The basic repeating pattern in a crystalline solid is what we would call a unit cell. Okay, and you can determine how these particles are arranged in your crystal. You can determine what's the unit cell experimentally using a technique known as X-ray diffraction. Okay, and the simplest we're going to talk today about the simplest type of unit cells, where uh, you have them arranged in cubes. The repeating pattern is cubic. Okay, so you have a simple cubic unit cell is one that looks like this. Okay, that's a unit cell. Notice you have a cube where at each of the 8 corners of the cube, you have 1, 2, 3, 4, 5, 6, 7, 8. You have an atom, a particle, or an ion at each of the 8 corners. Okay, and so this is a what would this be? That's several of those unit cells put together. Okay, uh, and so this is a cubic cell, so you can get a better visualization. Okay, so that's one simple cubic cell. You can see there is one atom at each of the 8 corners. All right, and if you want to show multiple cells, several of these cells together, then that's what you get right there. Okay, so of course there are really no rods linking those atoms together. They just, it looks like that. But the rod simply is is a good way for you to visualize the three-dimensional structure. So you have an array of these atoms arranged in this repeating pattern. So that's called a unit cell. Okay? And you can have what is known as a body-centered cubic cell. In a body-centered cubic cell, you have 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 atoms, one at each corner of the cube, but in the middle of the cube, you've got one extra atom. Okay? So effectively, how many atoms do you have in a cubic cell? In a simple cubic cell? Okay, you have to realize that each of these corner atoms is shared with how many other cells? Like this one right here, this is a corner atom, right? It's shared by how many cells? 4 on top, right? There's 1, there's 2, there's 3, right? And there's the fourth one on top. And there's 4 below, right? So it's being shared by 8 cells. So one atom in a simple cubic cell is actually shared by 8 cells. So effectively then, only 1/8 of an atom, you could say, belongs to a particular unit cell. So what's 1/8 of these 8 atoms? 1. So effectively you have one. You can say if you were counting atoms, each unit cell would account for effectively 1 atom. Okay. Now in a body-centered cubic, how many atoms effectively is contained in one cell, one unit cell? 2. 1/8 of the 8 plus the one that's in the middle. Okay. So this is what a body-centered cubic looks like. What if you have you can have what's also called a face-centered cubic. Look at what happens in the face-centered cubic here. At each of the 6 faces, 1, 2, 3, 4, 5, 6, you have an extra atom. Okay, let me see if I can make that visualization a little easier. Uh, Cubic, okay, this was the body-centered. Okay, this is your one cell. You got one in the middle. That's easy to visualize. But if you have face-centered, look at that. At each of the 6 faces, okay, so here's one face right here. Okay, this is one face, right? There's an atom on that face. So how many faces does a cube have? 6 faces. All right, so effectively, how many atoms belong to one cell if the structure is face-centered cubic? Okay. Each of these atoms and the center of a face belongs to how many cells? Let's show multiple cells here. Okay. See if we can visualize it better this way. Can you see that? Okay, let's look at this one right here. This is shared between, this face right here is shared between two neighboring cells, right? So a cell on a face would be shared by two cells. So effectively, only half of that atom belongs to a cell. So if you have 6 faces, but only half of those 6 faces, only half of the atoms on those 6 faces belong to the cell, 6 divided by 2 would be 3. Plus 1/8 of the 8 cells in the corner, that gives you effectively how many atoms belonging to a face-centered cubic cell. Total of 4. Okay. So this is face-centered cubic.
Does that one have like one in the middle?
No. Okay. The face center, there's one on each face in the center of each face, but not one in the middle of the cube itself. Okay. So that's what you call a face-centered cubic crystalline structure. Okay. So how many particles are in a unit cell? Let's do a quick review. Is it A, 1, B, 2, C, 3, or D, 4? For a simple cubic cell, how many? Is it 1, 2, 3, or 4? Okay. That would be 1, right? 1/8 of the 8. What about a body-centered cubic? Is it 1, 2, 3, or 4? Okay. This is a body-centered cubic. So you have 1, 2, 3, 4, 5, 6, 7, 8. 1/8 of those is 1 plus the 1 in the middle. That's 2. So the answer is 2. Very good. And for the face-centered cubic down here, how many particles are in a unit cell? Okay. Correct answer is 4. Very good. So that's 1/8 of the 8 corner atoms. That's 1. And then 1/2 of the 6 atoms that are on the center of the faces. That would be 3. 1 plus 3 would give you 4. Very good. Oops.